Hello everyone, welcome to this video. In this video we are going to see another basics which are modular arithmetic. Now by the term arithmetic you can very immediately think of counting. So modular arithmetic, that is another method of counting where we abstract it in a certain way. Now what does that exactly mean? That could be understood by the help of this example. Now suppose that is the month of August, right? So if I ask you what will be the month after 25 months from now, so there are two ways. Either you simply count on like this, so it is August, then it would be September, then October, November, December, January, February, so on. You count until you reach 25, right? That is one way, but that is a longer way and non-technical way. Another way is what? You can break this 25 like this. You know there are 12 months, so after every 12 months we are getting the month as the same month, so the month repeat after 12 months. So you could divide this 25 by 12 so that you have 2 as the quotient and 1 as the remainder. So that means when you count 2 years back to back complete cycle, so you are again going to reach at August. So that means if you add just 1 to August, you will be getting September. So September is your final answer, right? In a similar manner, if today is Thursday, I ask you after 10 days what would be the day. One way is to just count 10 days after Thursday and you will be getting the answer Sunday, right? Another way using this modular arithmetic is that you divide, because you know in a week there are 7 days, right? So after every 7 day you are getting the same day. So that means if you divide 10 by 7, what do you have? You have 7 multiplied by 1 plus 3. So that means you complete you go counting and complete 1 week, then after that you have 3 more days, right? So that means after 7 days you will again be getting Thursday, and then you can count 3 onto this. So next would be Friday, next would be Saturday, and next would be Sunday. So you see Sunday is your answer. So that is very simple as compared to counting each individual digit, right? So this is modular arithmetic. So this is the way where how we can count in an abstract way. So let me tell you more things. Modular arithmetic, it has several applications in mathematics as well as computer science. So how in mathematics do we use it? So first of all, as I have told you, you can write any two numbers a and n in this form. A is equal to qn plus r, where q is the quotient, r is the remainder. When you divide this a by n, right? N is the smaller number, a is the bigger number. So in that case, if this is so, then we skip this quotient and now we are interested in the remainder, because it does not matter how many complete cycles you make, you are just interested in knowing that how many are left behind so that you can count, right? So in this manner we just skip this q here, so that you have, when you divide a by n, so you write a mod n, that is equivalent to, here we write 3 lines, so that means equivalent to, that is equal to r. So we are here interested in the remainder. So it gives you the answer as remainder and not the quotient, right? So this is the formula and the way of writing it. So next you can see several examples here using this formula. If you divide 3 by 2, what do you have as a remainder? You have it as a 1, because when you divide 3 by 2, that you can write 3 as 2 into 1 plus 1, that would give you 3. So here 3 is the remainder and that is the answer. Similarly, when you divide 6 by 2, you will get the remainder as 0. So here 0 is the answer. Similarly, when you divide 11 by 3, so you can write 11 as 3 into 3 plus 2, 9 plus 2, that is 11. So here 2 is the final answer. Next, when you divide 62 by 85, now this is interesting because 62 is smaller than 85. So how can you write this thing? You can write 62 here, and you wanted to express it as a combination of 85. So you multiply 85 by 0 so that this quantity is 0, and just add 62 to it. So 62 is the remainder in this case. Why? Because 62 is smaller than this quantity 85 by which you are dividing it. So here the remainder is 62 only. And we can also perform this kind of calculations whenever we have negative numbers also. So suppose you wanted to calculate minus 2 mod 15. So that means we are interested to calculate what do we have as a remainder when we divide minus 2 by 15, right? So in this way the calculation is a little different. So how is that? So you can express minus 2 as 15 multiplied with minus 1, because in this way we are also having negative integers, you can clearly see, right? So we can have 15 multiplied with minus 1 plus 13, so that you have minus 15 plus 13, which would give you minus 2, right? So you have 13 as the remainder in this case. So this is one thing. Another thing, if you wanted to calculate this mod term for very large terms, for example, you wanted to calculate it for 27 multiplied by 36, which is quite a large number, right? And you wanted to calculate its mod 5. So how will you perform? Will you first multiply the two numbers and then divide it by 11 so that you see what is the remainder that is left behind? No. What we do in fact is we do it quite easily. We first of all calculate 27 mod 11. So we calculate it individually. So 27 mod 11 is just 5, because you can write 27 as 11 into 2 plus 5, that is 22 plus 5, that is 27. And similarly you can calculate 36 mod 11. So 36 mod 11 is 3. Why? Because you can write 36 as 11 into 3, that is 33 plus 3, right? So once you have their individual mods, so the mod of 27 multiplied with 36 mod 11, it is equal to 5 into 3 mod 11. Why we are again writing this thing? Because this number could again be greater than 11. So we might have to perform the mod, as in this case it comes out to be 15. 5 into 3, 15 mod 11. And what is 15 mod 11? It is equal to 4, right? So 4 is your final answer, and you see, using this kind of calculation, how easily you reach to your solution. So this is about modular arithmetic, and we'll be quite frequently using this in our course. So I hope you understood this one. Well, that is it for this video. Thank you for watching.